Max, I want to have a bet with you how many people are gonna watch us. How many hundreds are you betting?
Well, at least one, because I know my mama's gonna watch. So
Oh, hi, Max's mom. So today we're having our webinar, and it's a special webinar because I'm doing it with Max, and I call him a cheerleader of AI and IT, and in general of all DevRels existing.
very
So
kind,
I'm
Jenny. Very
especially
kind.
come on, I'm especially happy. I'm just coming here for 1 hour of praising, and guys, he's gonna praise you too. So today we are gonna build agents and even production ready, like it says here, and we're gonna using two tools, as you can guess from this screen. It's gonna be Qdrant and n8n. I'm responsible here for Qdrant. I'm Qdrant's DevRel. And Max is from n8n. He's senior DevRel of this low-code automation platform. And without a further ado, I honestly want him to start showing the cool stuff on it, and also start amusing with you, like, you with this agentic talk.
Fantastic. Thanks, Jenny. So let me share my screen and let me explain what N8N is, because we're going to be using N8N and Qdrant today to make the magic happen. So what is N8N? It's a low-code workflow automation platform, and we're fair code. So it's very similar to open source. The only difference is if you're commercially selling it to your own customers itself, there's some clauses around that. But for most folks, it's self-hostable, source available, and we also have a cloud. And if you are interested in checking out N8N after everything we see here, you can get a sneaky 50% off for 12 months using my max50 code. All right, enough shilling. Let's get into what N8N is. So N8N is a workflow automation tool, as I just said. And so what you're seeing in my screen right now might look familiar if you've been in this space for a while. We've got multiple steps on a canvas. These steps do things, and together they can automate a process, right? So a process could be a human process at work, maybe it's something to do with accounting, but a process could also be an API endpoint, for example. That's a process. It's manipulating data, outputting it, it's receiving that data, etc. So that's what n8n is, and that's what we've been building for the last 4.5 to 5 years now, is a really mature solution for all the kinds of steps you need to run it, all the kind of scaffolding and infrastructure around deploying that, monitoring it, etc. And there's sort of hundreds of different nodes and actions for all that sort of thing. Now, what I think makes n8n really powerful these days is that a lot of these steps are now AI steps that we've added. So there's steps for things like sentiment analysis, these sort of opinionated things that you might want to do and don't want to have to rebuild completely on your own. Same thing with things like text classification. In here, I can define those categories myself and classify by my own things. But the hero of today's show, or one of them, I should say rather, is our AI agent in n8n. And so again, this is a step in a multi-step workflow like any other, but it's really good at handling fuzzy inputs like natural language and all the sorts of things you might have been hearing about AI agents. But to underscore that in n8n, since we're a workflow tool, an AI agentic step is just that. It's a single step in your workflow. I think one thing I see in this space very often is, all-in-one AI agent builders try to do everything with an AI agent because that's all they have. In a lot of cases, if you need to do a simple if check, you should probably use a simple if. It's going to be a lot faster and a lot cheaper for you. So today you're going to see use cases where I'm combining these sort of deterministic steps, like you see here, with AI agents to do really really powerful things, but that are also predictable because we're adding guardrails and specifically telling what our AI agents can and cannot do. So, what is an AI agent? To define that, let's quickly define what an LLM is, or a large language model. So a large language model, how I like to think of them, I'm not a scientist, by the way, but how I like to think of them is as a function. They expect some sort of input, very often a user message, and they will output an output. Very often they're predicting what should be next. So an input comes in and predicts what should come next. Sometimes it's seen as an answer, but there's a lot of limitations to that. And what an AI agent is it's goal based, and that goal is to complete a task that you assign to it. And then it can make multiple thoughts, as I like to call them, under the hood, or actions, for example, to interact with tools to complete that task, and then determine once that task is complete, and then output that result. So let's do a quick example, and then I'll show those sort of steps happening. So if I click the chat here, and This is connected to the Hacker News tool. So it can fetch tools, or it can fetch articles from Hacker News rather. So let's see, what are some interesting articles on AI topic? And let's say maybe instead, let's some popular. So now what's happening, we can see it's connected to the window buffer memory first. So it's fetching to see if there's any other messages in this thread if we were having a conversation. It then invoked the Anthropic chat model. So I'm using Claude 3.5 here, which then decided to use this Hacker News tool here. It sent an input of AI as the keyword. So the AI agent decided to use this AI keyword based on my request. Once Hacker News returned its output, the AI agent again decided it needs to think. So it thought on those inputs, and it decided it has everything to output an answer. And here we can see, based on the results from Hacker News, here are the various things happening here. Now, when you're using something like ChatGPT, that's not a pure LLM. It's using a lot of agentic concepts like you're seeing here, but this is basically what's happening under the hood. Multiple thoughts are occurring that it lets it do more complex things. And the nice thing about tools in n8n is those themselves could be other workflows or other AI agents. So you can get into multi-agentic workflows and really take very big problems, break those down, model them into discrete chunks, and actually have AI agents autonomously doing a big chunk of work, things that previously weren't possible with just deterministic steps, or were a lot more brittle and a lot more effortful to get done. So that's n8n in a nutshell, and AI agents in a nutshell. We'll be showing a lot more on using those, but I think Jenny is going to first arm us with some context and foundation on the stuff that we're going to be using with our AI agents. Over to you, Jenny.
Okay. Well, that was amazing, man.
Thank you much.
When I present like you, it's gonna be my best days. Okay, guys. So coming to my slideshow, and I hope I am sharing it. So let's talk vector databases. Once again, we're gonna back and forth, each of us talking about our favorite stuff, but like, you know, today we're combining both of them. So when it comes to vector databases in agents, everybody like uses them now as a knowledge base. So when it comes to talking about anything agentic, usually people say, okay, agentic RAG probably. So we're just gonna use a knowledge base, a vector database. We're gonna use a similarity search on it. We're gonna, for example, put in our documentation or our professional literature, like chunk it, toss it around, and we are gonna use it to retrieve the information, give it to agent, and, for example, do a chatbot with our users. And it's a very smart solution. I am not saying to you that it's not the thing to do. Why? Well, we can, of course, use like APIs like Hacker News, like Max showed before. We can use internet. We can use even some other types of databases. I'm not gatekeeping anything. But in general, it's one good application for agentic use cases, because with vector databases, you can use similarity semantic search or hybrid search. They are scalable, and they're actually very good as a knowledge database, because you can put specifically the data you're interested in. For example, your documentation, when in the whole internet, you have so much stuff lying around that the retrieved information might be irrelevant. So when we're talking about vector databases as a knowledge base, everybody knows it. But has anybody told you that we can use them as a big data analysis tools? I think no. Because mostly, okay, I just read a lot of blogs out there, and I think this part of vector databases, this very, very interesting nature of them, people kind of undervalue. So I'm here to, like, you know, to stop this nonsense. And I'm going to tell you how to use vector databases as a tool for agents, but use them for classification, outlier or mislabeling detection, anomaly detection, and they can be also used for many, many other things like context-based search, exploratory search, yada, yada. But if I'm going to give you all of them, I mean, we're going to sit here till tomorrow. So I'm going to limit myself a little bit. And the interesting stuff is why? Why can we do so? Well, a very simple idea behind the vector databases, that it's just a storage of any vectorized data. And you can vectorize any data. You can vectorize whatever you want. It can be a video, an image. It's all the matter of embedding model. And then you are vectorizing your data and putting it inside the vector database. These vectors, these points in the space, are grouped together based on their similarity. And their similarity can be measured by different metrics. But for example, it can be a metric of a cosine similarity. This one depends on angle between these vectors. I don't want to be like annoyingly mathematical or whatever, but it gives you two very important things which are very interesting. So the similar objects by some category, some feature, some class, some idea, they are going to go together, and different objects are going to stay apart. And by these two facts, similarity and dissimilarity, you can actually use it to solve so many problems of analysis. I mean, for example, look at that. This picture I took actually out of our data set that we're going to use today, and I'm going to show you how to generate this nice picture in our Qdrant dashboard. It's basically data points, image data points of the cropped data set that I'm going to show you later. But look at them. They are grouped together based on their classes. You can see clearly the clusters coming out here. And looking at this data, firstly, you can guess how your data works in general. So you can understand what's grouped similar by the judgment of the embedding model and what's apart, what is your anomaly, what is the variety of your data, what can you find if you explore it, how various it is there any outliers, are there any problems? All of this you can just do by looking at the embeddings, looking at the mathematical representations. And it doesn't matter which modality of data you're using. Is it like images or audio or text or whatever? And everybody forgets about this. So today we're going to try to do the classification and anomaly detection, which is pretty intuitive. I mean, look at this picture and you can immediately see how to maybe approach this problem mathematically or like, I don't know, more hustly. So the first one is the classification. Of course, when we are talking about the classification, people will literally roll their eyes and be like, okay, come on, this problem is solved. It's 2024. We have AI agents. You're talking classification on the webinar. And I understand. I mean, I have 7 years of machine learning education, guys. So if I would be talking about classification there, people would be literally just excluding me and taking away my diploma. But like, you know, the thing is, classification is easy unless you do it in production with the real data, with the possibility of data drift, when in real time, new classes arrive, data starts looking different, the distribution of it shifts over time. You have billions and billions of data. You don't have enough labeled data for your specific use case in production once again, and you don't know how to label it. I worked previously at crowdsourcing, so I know kind of that people don't know how to approach this problem. So, you know, nobody thought that you can use a vector database as a classifier. And you can use it actually. And the simplest first step, which I'm going to show you without any fine-tuning, even though you can do some fine-tuning, it's called metric learning, but it's for the next time, is just to use nearest neighbors. So you have a little bit of labeled data for you, and you just put a point in your vector database, you look at its neighbors, you do the majority voting among them, and then you kind of guess the class, because like, you know that in vector databases, similar points are similar and dissimilar are dissimilar. So that's what we are going to do. One of the tools that our agents is going to use, going to be a simple nearest neighbors classifier. The second one is Max.
Oh, sorry, Jenny. I was just going to ask quickly for the folks at home thinking about, we're building something that can classify, and maybe they've popped an image into a vision model before, and it's also classified it. What's the benefit? What's the difference of us sort of doing this today versus a sort of naive approach like that?
Yeah, the difference I would say is firstly scale, because like, my favorite question from the last webinar was with ChatGPT. Like we were doing this optimization of Kalpali embeddings, and the person comes and asks, hey, why can't I do it all with ChatGPT? And I'm like, Bro, I mean, of course you can, but it's just like extremely slow because like when you need to work with 1 billions of data, say you're working on a real-time conveyor, my favorite one case is automating vertical farming. You have billions of images incoming, you need the fast classification, you need something very, very like optimized for this. And since vector databases are pretty much optimized to work at scale, like at billions points, I think this is the only fitting solution. Or you have a very nice like machine learning updated retrained classifier if you have a good data at your source.
Thank you so much.
Man, your questions are popping in the right time. Ask them more, please. So the next thing you would ask is, okay, I kind of can guess out classes, but what if there is some point which is coming and it doesn't look like it belongs to any class? Maybe it's going to be an anomaly. How would I detect that? And here, actually, I had a lot of fun because we didn't do it like this before because it was using a little bit of our new API function. But I thought of a couple of ways to do the anomaly detection with vector databases too. I don't know why I'm showing off, guys. I just sometimes like to do demos for fun. And that's how it turns out to be webinars. But like, the logic is also what I like as using like vector database as a tool for data analysis. It's pretty intuitive. So for anomalies, it's also pretty intuitive. Anomaly is something which doesn't belong to any class. So it's somehow floating in the space. There is a point which is not similar to any like area of our classes. Okay, so we just need to understand that it doesn't belong to these areas. Well, then the algorithm is just coming by. We can just literally identify these cluster centers. We can look like what is the area of these clusters. We can just check what is the difference between the center and the furthest point within this cluster. I mean, of course, considering outliers. We can calculate it as a threshold. You can look here. This threshold is basically the area which is colored. And everything outside of this threshold is going to be an anomaly. And then if nothing, like if our new point that we are trying to put in the vector database doesn't belong to any class due to our thresholds, then it's in general an anomaly. And then alert, our agent, for example, can stop all the process. Imagine if it's like a conveyor, or even better, well, I don't know if we can use it in medicine, but it's important to spot anomalies in many businesses, right? So the only question was how to understand what is the center of this cluster. And I think the approaches can be countless, but I had two in my mind, one more mathematical and one more hustling. So let me show you both. So the more mathematical one is using the medoids cluster centers. So Qdrant, since our 12th version, provides a distance matrix API. So it basically returns you distances pairwise between all the vectors, all the points we have. Of course, it's a very computational heavy method, so I don't recommend it to do on the big loads, more than a couple of hundreds. But if your clusters are small, so your labeled data is not so much, you can do this thing. You can get this distance matrix. Of course, it's based on your on the metrics that you use of the similarity between vectors. In our case, it's cosine. And then based on this distance matrix, if I know how similar or how close all of our points, our objects vectorized are, I can find the most similar to all the others object within the cluster. So the perfect representative, like for example, if it would be a cluster of candy images, it would be the most candy as the most chocolate, the most beautiful candy, the most representing it. And this is pretty easy to do with a distance matrix, because when you have distances, you can just select the row with, in our case, since we're working with cosine, so the most similar is with the biggest score. So it's going to be the row with the maximum sum. I know it's a little bit maybe hard to digest at this pace, but I am definitely going to explain it more and more. The thing is, it's pretty simple now. You call an API, you do the sum of the rows, boom, you have your perfect representative. However, Mhm.
Jenny, I was just going to ask, for the folks of us that don't have an ML background, present company included, could you explain what the cosine score is? Like, what kind of values are we expecting, and what does that mean?
Oh, yeah, absolutely. So here, I think I skipped this slide so fast because I am like this professional yapper, which yaps too fast all the time. So if you look at these two red points, and you look that there is basically this green angle between them. So the cosine of this angle is this similarity matrix, but it's not important. And what important is, it's one of the most popular measures to check how similar the vectors are. So if it's close to 1, that we know that these two vectors represent a very similar objects. For example, they represent, if it would be a pictures of people, it would be twins. The pictures of twins will have a very high cosine similarity score. And if it would be a picture of a baby and his grandpa, which is generationally we look very different with age, they would have a very different cosine similarity, so close to -1. It's all the mathematical ways to basically make your data look similar or dissimilar, which is this feature of vector databases, which allows you to do a lot of analysis of your data.
So, in other words, the closer that the cosine number is 1, it means these 2 points are most similar, and the closer it's to -1, they're most dissimilar. Is that right?
Absolutely. You
Very
got
cool.
it.
Thanks for
You
clarifying.
got it. Yeah, I think it's literally a little bit hard when I am trying to wrap Eminem out this cluster center methods. But I swear to God, guys, the idea behind is very, very simple. We're just using the similarity and dissimilarity. And when we're similar, we're alike. If we're dissimilar, well, we're dissimilar. And that's how we're using the information in vector databases for our data to be grouped together. So the second way, which this one is mathematical, it's a little bit complex. It might be interesting for guys in data science like me who are like to dig in the APIs and whatever. But of course, most of us, we have a situation when we have a lot of data and we want to use also something more AI-ish and fast. So the second approach of finding a cluster center is going to use actually the features, the specifics of our data. So here in this project, I'm going to work with images, but I'm going to use a multimodal model. That's exactly what we were stating, that we're working not only with images, but also with text. So when we're working with multimodal models, we can actually use textual descriptions to describe our image. And then the most similar to this perfect textual description point in our class is going to be the cluster representative. So our perfect, for example, cherry, like we have here, I write a textual description, I embed it with my multimodal model, I get the image which is similar to it, and boom, we have a cluster center, we have cluster borders, we can detect anomalies. So that was a lot of theory behind it. And of course, you will need some time to process it. But the most cool part that we're going to show it practically, because as I promised before, and as Max promised before, it's talking about real use cases. So here I am going to show you, with the help of Max, building tools on the vector databases on these 2 Kaggle datasets. I tried to find the most representative of the real use cases. It's going to be a crops image classification dataset. It's just the pictures of the different crops and the satellite imagery. And I'm going to use a multimodal model, which is called Voyage AI. It's working with images and text. I am not saying that it's the most perfect model for every use case. You can try also Clip. You can try also models of 12 Labs or Nomic. But this one worked perfectly. Remember, it's always important to select the right embedding model for your vector database. So finally, why I was saying real use cases and then I was dumping the 30 minutes of mathematical stuff on you, because this particular use case, this particular pipelines that we're going to provide you for anomaly detection and for classification with no labeled data, with different use cases, with difficult data shifts, it's actually applicable to many, many, many businesses. Because what I'm going to show and what Max is going to show, it's actually doesn't matter which data you have, you can swap it. You can swap my crops with whatever you have. And then basically on this image and text cases, anomaly detection and classification, you can do whatever. Think vertical farming, think food industry, like automating conveyors, think rescue operations, like you look through satellite imagery and you find a missing person in the forest. It will be anomaly detection. Think ecological monitoring. You can, again, with anomaly detection, identify if there is somewhere an island of garbage or an oil leak in the ocean. You can do some recruitment matching platforms because they are going to do like a specific classifications with the vector databases of CVs and suitable positions. Because this is very hard to classify with some machine learning algorithm, but you can just take embedding model, you can take our pipelines, which we're going to provide and publish afterwards, you can swap the data and it's going to work. So without the further, actually with a lot of further ado, I think it was so many, you can obviously contact me and we can talk on LinkedIn your use case based wise, and we can think how to use it. But I don't want to now answer too much questions if there are any in the chats. I want to immediately show you that one can build all of this, and it sounds more complicated than it is to build. And then when Max is going to run agents on top of this tooling, on the top of this vector databases, it's going to be a pure magic. So let me show you what I have. And I think the coolest stuff here, Max, I think I am building this like on n8n, like what, second time in my life?
And how's your experience so far?
Man, it's oddly satisfying. But I swear to God, I was so impressed that I managed to do it, even though I am like logging in the platform second time in my life. My workflows are a little bit ugly, guys. So before I will publish them, Max promised to look for the best practices. But one cool thing that all of them are working. And Max, you said they are pretty representative, aren't they?
Yeah, I think so. So Jenny has a few code blocks and stuff that you'll see in this. And I think like unlike a lot of other tools, why we call ourselves a low-code tool is precisely because we don't demonize code. If you know how to code, very often that is the most efficient and explicit way for you to express yourself. And we don't think you shouldn't be able to do that. If you can't, there's also no-code ways to do things. So Jenny, code or no code, you're all good in my book.
Yeah. So guys, there is going to be a couple of parts in this pipeline. First of them, more preparatory, and then exactly the tools which agents are going to use. So the first important part is basically uploading data to vector database. In our case, is Qdrant. So we are uploading our crops data. As I told you, we have two data sets. It's crops and it's landmarks, like satellite imagery. So as you can see, I have my data sets on a cloud storage, and you can even see that they're actually one of crops. There is this complicated system of folders, and I want to embed them. So
and Jenny, as a quick question before you jump into this, for the folks at home looking at, okay, I see this sample set, maybe think about some use cases that they have at work. How many sample datas or classified sample datas do they need to consider this use case? What's that theoretical minimum? I'm sure it's a range. I'm sure it depends. But is there a theoretical sort of minimum you could propose?
I would say a couple of hundreds are enough. That's why what is the plus with vector databases. You can start working with unstructured data and the minimum of labeled use cases, and it's going to work.
And is that total or is that per class? So like let's say I want to start identifying cucumbers. How many cucumbers should I have ready?
I think 10 are good. Like you don't need much.
Okay, so like a realistic number that even like an individual small business might have. We're not talking like enterprise scale data.
Yeah, no, absolutely. That's the plus. Like, you don't have to order a project with a crowdsourcing experts gathering you thousands of labels. You can label it yourself, throw it in through the same Voyage model, use our free tier cluster in Qdrant that we showed the QR code. Boom, you basically as a classifier. Then open n8n, download it, throw in whatever agent magic you are going to show later. Boom, you have a working agent which classifies crops for your small business. That's why I like it. Like now you can build whatever, right?
Yeah, that's very cool because I think the misnomer, especially when I was getting into the AI space, is I assumed you need a lot more big data. Maybe that was true previously or more, less obtainable for folks, but it's truly amazing how little you need again to make something like this useful. Anyways, thanks for my interjection. I just really wanted to know like what that from a source, a reliable source like yourself, because you're building these things as part of your work.
Yeah, that's what I like. Like now you are working with the big data. You can basically leave it to the database. You can leave it to like n8n, and they're doing the stuff for you, right? Because you don't have to do much preparatory stuff. You have all of these beautiful nodes, right? They're doing a lot of work behind them under the hood. We don't even like see it. You just have to select the node, click, put it on the canvas. You're building the whatever it is, it works. And you can set up like a working pipeline for your business even without trying to connect 1 million APIs. But I think I'm spoiling too much, right? Because you're going to show it with agents.
A little bit, but that's okay.
Okay.
So please, without further ado, go ahead.
Yeah.
And we've also got a question. I think that was to zoom in a little bit.
Oh, yeah. I didn't even start, guys. Don't get worried. So whatever happens here shouldn't scare you. It's a lot of nodes just because, like, as I said, I'm building a second time. But all of this was pretty clear to me. So it's actually yet another proof, guys, that it's pretty easy to build pipelines that are working. And what happens here is actually a lot of API calls because I'm using Qdrant. I'm using different features of it and regrouping data in a better way. So here I am uploading data to our vector database, to our cloud, Qdrant Cloud. And I want to show you what do I mean by that. So here we have our UI. It's also with the cloud, but we also have it like for open source local version. Everybody can have these dashboards. And here you can see my collections. They're already uploaded. But of course, I'm going to show you in real time, and I hope without any mistakes, how to upload them. For example, this is the collection of the crops that I mentioned. And in UI, you can look at them, their beauty. This is what maize looks nice. So yeah, here I want to upload this data set of 810,000 points. Let's, for example, do crops, but for the landmarks is the same. And this pipeline does exactly that. So it creates this collection. Collection is the storage for your business problem. It basically takes my data from here, as I said, from the storage. Depends on where your data is stored. Maybe you take it from the internet. I don't know, depends. Then it aggregates it. And here I regroup it. I regroup it in batches because I always think that batch uploading is better because you don't call API too many times. So I'm calling here Voyage API. Voyage is this multimodal model that I'm using for embedding images. And then I am batch uploading it to Qdrant. So let's run it. I want to create a new collection so you can see that it works. For example, we don't have a test one. We don't have even a test one. So let's just do it like this. And let's run it. So we have some action happening. And since embedding with a Voyage model takes some time, let me show you actually what I meant as a vector databases as a data analysis tool. So for example, we have these crops uploaded here in our vector database. And let's look at them, how they are actually grouped into the vector space when they are embedded as vectors. So here you can see in the visualization, oh my God, each time I'm looking at it like a cat looks at the Christmas tree. So nice. But you see that even without any fine tuning, even without taking a specific like models or whatever, our images, our crops are grouped together because Voyage model recognizes these images have some intrinsic similarity to each other. For example, or old cherry looks kind of like cherry, and here is a cluster of these cherries. We don't even have to label them because this is colored by labels, but we didn't have to have these labels. I'm just lucky to have them to demonstrate to you. even though the same labeled data is grouped together in the database. And you can throw in thousands and thousands and millions and billions of points, and it's going to work the same. And that's why I think it's pretty cool, because already here you can see that this is kind of an outlier of the class. What is this? Foxnut. Max, do you know what is Foxnut?
My agrarian background is a little bit light, so unfortunately not.
Oh my God, I should study better these days. But yeah, and this is our cherry cluster, which looks pretty much like a cluster. Okay, so let's come back and see that everything has run and uploaded. And now in UI, we can actually check that we have this new test collection. Perfect. Then the second preparatory point after that is to set up these cluster centers and cluster thresholds. As I was showing in the presentation, this is the way to detect anomalies. We need our centers, representatives, and our cluster borders. So this is my beauty, lovely. I think it's my favorite out of 3 because it's like a little bit brunchy. And it does exactly what I explained in the presentation. The upper branch does the mathematical way, and the lower branch does this textual description way. Once again, nothing scary here, mostly API points. Most of them are like just for the sake of making it more optimal. My favorite here is our cluster distance matrix API that we call to get the distances. And of course, I use the code node because like I just can't help myself, okay? And here we're using a textual descriptions, which could be done even smarter in n8n, because here I just hard-coded them, like, you know, to embed them and compare them with images. But actually you can use open, like, I don't know, OpenAI model, which creates, can you, Max? Can I just like send a picture in n8n and it will return me a textual description, right?
So there's various image models we do work with. Yes, you could pipe that. You don't even need, let's say, an agent for that. You could pipe that into a vision model and then get a response.
Yeah, so you can do it right here, but I did it like, you know, more hard-coded way. And here, nothing scary happens once again. We're just setting this centers, like IDs of our points in our database. We say that it's a cluster center for each crop, and then we set a threshold score based on every method. And once again, let's run it for our newly created collection, which I called, I think, test. And it hasn't been tested, but it should work. Look at this. It runs. Like, I swear to God, each time.
Oddly satisfying feeling of seeing it go green.
No, yeah, you don't say.
You know what I'm talking about.
Yeah, I know. No, I swear, it's so nice. And now we can even see it in UI. And that, for example, I showed you guys before that we can color them by our class, so crop name. So it was like what, like cherries, lemons, or whatever. But now we can also color them and see what our methods set up as the centers of these clusters. So for example, the coloring is a little bit not so contrastive, but for example, you can see that in this cluster, our center, our representative is this one. Looks pretty central to me, right? So this is the perfect pineapple for our mathematical model. And now it's going to guide our cluster borders. So out of these cluster borders, everything will be anomaly to our pineapple class. Well, but it's going to be seen in practice. So yes, and the last step, I mean, one of the last steps is to show you a tool which is actually going to be used by an agent, an anomaly detection tool. And it's pretty small, but it's pretty powerful. So basically, you put in any image. There is a mock image. What is that? I think it was something like cotton. Yes. So you can plug in any image, for example, this cotton image, but I hope Max will give a little bit more variety to that. And then it's going to run, compare like everything to our clusters. And it's going to either say that it's an anomaly, or it's going to say that it belongs to a known class of crops. So what was our collection named? I think it was named test, but we can also check it on already existing collection. And it should output that looks similar to cotton. It indeed does. Okay, so I set up everything. Now it looks like we can let our agent do something with this anomaly detection. So Max, I am willing to see what have you prepared for us.
That sounds like a cue for me to share my screen. So thanks a lot, Jenny. Really powerful stuff there. I think what's really cool and to underscore is that the workflow looks simple, but Qdrant under the hood is doing all that complicated machine learning, mathy stuff to make it easy for you. And that's true with the AI agent as well. So this is my AI agent. We're going to run it in a sec and break down all the different parts so you understand how it's working. But this AI agent is using one specific tool. That's the classify image tool, or sorry, that's the anomaly detection tool. And so what this is doing is it's calling the workflow that Jenny just showed us. So if I open this, I could open this workflow here, open it up, and we can see this Jenny's workflow here. I'm sharing a tab, I see. So we can see this Jenny's workflow here, right? So if I go back to my workflow, we're consuming Jenny's workflow. Now, the nice thing about that is I don't have to understand how Jenny's workflow necessarily works. I need to know what I need to input, so it expects an image URL, and I need to know what I can expect to output. And there's two cases there, right? Either it is an anomaly or it isn't, and it tells us the class that it is. So when we're talking about production, that's kind of one of the aspects I'll highlight here. It's not really something you're seeing in code, but it's something that you're seeing in terms of the way teams and people work, right? Like Jenny or some other team could own with, we've got user management, could own this workflow. I can access it. I don't necessarily need to be able to edit it or understand how it works. I just need to be able to consume it as an analyst, as a builder, as someone in marketing, what have you. And very often I'm seeing that the domain expert, the person who knows how to do the task the agent's doing, which isn't always necessarily an ML engineer, can actually be a lot better at some of the prompting and stuff because they understand the context of how to do that job. Okay, so we're using a tool. Let's run the solution, and then we'll pick apart how it's working. And to do this, I'm going to demonstrate this within an form trigger. So we're going to serve a web form, and then I'll show how I manipulate this, or rather I turn this into an API endpoint to show that kind of flexibility, how the agent and then the way you're consuming the value of an agent and the tools that it's using is completely decoupled, as it would be in native code. So let's click test workflow. And I'm going to share a tab. This just popped up. So this is a test form. If I publish my workflow, this would also be a web accessible form. And here we've got the image to analyze. Now, again, I'm using a simple web form here, but this could also be something that you're hosting via webhook or pulling in through a different app, etc. So let me upload that, and let's get let's see, a Qdrant demo, and let's get a papaya in here, and let's upload that. Now, this is a photo of a papaya that I found. This isn't from Jenny's set, right? Because I think that would be cheating. And so it doesn't look very pretty, but again, we're showing the data and how that's working. The way you consume it, a front end is a front end. You could modify that as much as you like, or your front end team could, right? But here we've identified it as papaya. Okay, let's go back to my workflow. Oh, looks like we've lost that. 1 sec. Let me just share that again. Okay. So
Max, I swear to God, I skipped the papaya. Can you show me once again?
Was the papaya not being shown?
I think the papaya JPEG was shown, but the papaya itself.
Okay. Well, we got to show papaya. Okay, so let me share the whole screen so we can see the pop-up and the papaya and all that. Sorry about that, guys.
Yeah, I'm not missing a papaya on this webinar. I'm sorry, guys. We are looking at this damn papaya.
All right, we're just going to quickly share my whole screen. You sort of a little bit sneak behind the magic. And let's just run this again. So I'm just going to test my workflow. I see this pop-up screen. We're going to open up this, and I'm going to add a papaya. So here, papaya, I think we'll all agree. It is a papaya, by the way, if you're not, again, a horticulturalist. And let's run this. So it's run. The workflow is running now. Our AI agent's using our tool. As you can see, it's returned the results of the tool. The AI model ran again. We have some structured output, which I'll show that in a moment, which we're able to give a structured response to my web form to be able to serve this message here. And if it was something anomalous that we detected, we would show a very similar message and just show that it's anomalous. Okay, what's happening? So the form trigger runs and it creates some output data. That's some binary data as we call it n8n, but we have a file here. And then we have an S3 node. I'm using I forget which S3 service, but it's a generic S3 protocol here. So you can use any basically S3 protocol compliant data store. And I'm uploading it to my bucket here. I'm using n8n expressions to compile the name of that image. So I've got the ID of the execution. This is all in JavaScript, essentially what's happening in here. And the file extension of this image. So if a user uploads a PNG and whatnot, that's all uploaded how I like. But again, this is not an AI step. That's just some of the utility stuff we got to do to have it ready to pipe into my AI agent. And then in my AI agent, we've got the agent itself. We've got the OpenAI chat model, the anomaly detection tool, and a structured output parser. So let's break this down. If I open up my AI agent, it is receiving some input here. So it's receiving actually all data coming in. And we can kind of define and control what it sees, basically. And if we look through the parameters here, we have the text here. This is also known as the user message in a lot of contexts. And if I open this up, we can see that we have a static prompt here. So this is not a chat case, right? Like I don't want the user to, from the form, to have to define it. I want predictable result. And so I have a predictable user message. And I also pipe in the image to analyze here. And again, I've got some static part, and I'm combining with dynamic data that's being piped in at runtime from my input data. We're also requiring a specific output because I want structured JSON coming out of my node. So here you can see we've got an output object coming out. Is anomalous is false. This is what I use in the if node next. And then the probable known class. So if I go out of my node, we can see because we're using this structured output parser here, if I double click on that, looks very simple here. All I've provided is a basic example. And as you can see, I've only provided the example for one case. I didn't even need to provide two cases. Now, if you want more control, which you might want for a very complicated object or an object that can look very sort of different on the different cases, we could also define the JSON schema manually, where we can then define the data types and all that sort of thing. But being honest, I've never needed to use this on a production case. The example's been fine so far. So this structured output parser, combined with the required specific output format toggle here, is giving me a predictable output that I can rely on for my deterministic steps in the rest of my workflow. And then I have a simple if check that then routes to basically respond to form node, which is part of n8n, but this could be any other node in my workflow. And then in here, we're delivering that message, informing the title again through expressions, using that probable known class that's being piped in there. And same for the message. And then for the anomalous case, it's static, right? It's anomalous, so there's nothing really to provide in there. I guess the other thing that would be interesting to point out here is that in this specific case, I did not need to provide a system message or anything like that. There's a default one. You're a helpful assistant. In the next examples we'll get into, there'll be sort of a lot more in that. But yeah, this is a fully working AI agentic workflow that I could publish. And now that it's published, this web form is something that you could go ahead and run. If I go in a new tab, this is now a web form that can do this job. Now, let's say I didn't want this as web form. Let's say I wanted this as an API endpoint instead, to consume headlessly or to start selling as a service to people that need to be detecting anomalies for this specific thing that we basically trained up. Now, I was going to build it out. We're running a little bit behind time, so I'm instead going to do one of those classic cooking show things and show you this is one I made earlier. So we're going to quickly navigate to that. And then what you're going to notice is this looks exactly the same. It is exactly the same. What changes is basically a few of the nodes on getting the data in. We're doing some validation on the input data because this is coming from a user. So maybe there's a malicious actor. So showing how we can handle some things like that. We've also got the same check on the end. We're just using n8n's respond to webhook node. So in here, if I see, I'm basically just defining a response body, as I would expect, in an API endpoint. And then also AI agents can error out sometimes. I didn't model that in the web form because that's, let's say, a little internal web form turn to use, but this is an API endpoint, right? It's production. So if this AI agent errors out, which again, LLM models can error out and timeout and that sort of thing happens. I can also, because in the settings here, I am continuing on error, I get an error output. And I then have a different respond to webhook node where I'm giving an error message, and I'm even through the options have been able to define a quick response code. So when I consume this workflow, it looks and feels like an API endpoint. That is, if I take this post URL and invoke that and provide the body parameters that it expects, which is essentially it's just expecting an image URL, this will allow me to use that tool that Jenny used. Now, again, this AI agent doesn't have to understand how Jenny's tool is working, nor does the AI agent, or nor does the person consuming the endpoint have to understand how this works either. So 2 levels of abstraction, and your end user is far away from being able to inject anything in the prompt. And what you're seeing here, there is very little, if any, vector for the user to basically prompt inject, because it's not a chat use case. So why would we allow them to basically be adding that much fuzziness in the input when what we're expecting is a predictable output response, i.e. an API response? Back to you, Jenny.
Max, I think we did a huge mistake. We didn't show an anomaly.
Should we show an anomaly as well?
I think you should upload any photo you want, like even if you have a selfie or something on the computer, and let's see if it's gonna be detected as anomaly. Well, unless we all look like bananas, which is
cool. Well, thanks for keeping me honest. Let's definitely do that. Let's see. Let's go in my downloads folder here, and no, that looks like all right. We've got a golf course.
Yeah, let's try a golf course. That is definitely not a crop in my book. Let's see, might be a blooper in real time, and then people will judge me for ages, and I can live with that, but let's see.
Okay, so as you saw, that was my downloads folder that was not well organized. I forgot to prepare that case, and here we can see it had detected an anomaly. That's actually a satellite scan we're going to use in the next example. So yes, it's working. So it's identified the anomaly case and the known class case. And since this is the exact same AI agent using the exact same tool in the API version, you'd expect to get the exact same result given the same image.
Well, now we look absolutely and completely honest. I see so many confusion in chat, guys. I'm so sorry because I was so fast on showing everything. I promise to reiterate everything through Q&A. And also, I mean, when you watch it once again, it will be more understandable in a slow-mo because I feel like I'm speaking to X now. But yeah, let me show you once again. Why do I mean once again? Let me show you a new use case, a classification. And this is also a very simple tool. I mean, it looks not so big. It's just like, you know, a couple of nodes. And it also uses a vector database. I saw a question in the chat, like, how are we even using vector database here? It's all done through HTTP nodes, because when you have an API in n8n, you can just call this API. And our API takes a lot of different calls, so you can do whatever with it. Upload data, search data, recommend data, do every yada yada with data that I talked about today. So this n8n classifier tool is also pretty simple. Now we're switching the data, and it's not crops anymore, no more papayas, it's terrains. So we have all of this list here, like, you know, forest, freeway, golf course. And this data set I also took from Kaggle and uploaded it to my bucket. You can see here actually what is that, so it doesn't sound like too complex. And if you can see, there is like test, train, and validation. So I'm going to actually test my classifier on this test. Wow, that's tautology. And here we can see how the images look. They are also getting embedded. Like, what is this? This is just buildings from the satellite. And all of these images, once again, are run through the embedded model. So Voyage API here. And when they are embedded into the vector form, they're all in the Qdrant in our vector database. So once again, to show you, it's here. It's here in the collection, and we have them uploaded and in a vector form. So here you can see that there are vectors of the 1000 of the size 1024. And these vectors are gonna get classified into the classes. We have classes saved. So here, what it does the same stuff that I showed you in the presentation of the picture. To reiterate, it just checks the nearest neighbors, and it says basically who are closer to me of one class. For example, it's like a harbor. If there are a lot of harbors next to me in the vector space, judged by the cosine similarity, then the image that we are uploading from agent is a harbor. So I honestly hope that it's also gonna work. So far so good. Whatever we did worked. I saw some brilliant comment that the demos working on the webinar seems like a black magic, and I agree. Usually it never works with me like this, but let's see. Should also work. And thus here we have a test image URL which Max inputted as. We have here. What is that? What is that?
That's a very good question, Jenny.
Oh, what is that? Hell knows. I think it looks like fields or like forests, whatever that is. And it actually runs this classifier. Here there is a small loop to check if there are ties in the amount of neighbors. And it tells us that it's actually a harbor, which is suspicious, but I don't know. Let's see. Maybe it was another image, or we have a harbor here. I clicked it. Guys, now you know that I work with n8n second time in a row, because we have in a test workflow points harbor.
That's my bad. Sorry about that, Jenny. I was testing this
You
beforehand.
set
I
me
own
up.
that one. I did.
You
That's my
set
B.
me up, so I look bad on the weather. I know now, but no, guys, it was actually a harbor picture here. We can even check it in real life, and it's a harbor. Yes, and now I guess we can check what our agent is going to do with it.
Okay, so let me share my screen. And so what I thought would be kind of cool is to show our AI agent interacting with multiple tools, actually creating records and this sort of thing, right? So getting a bit more involved in things that we might consider as a little bit dangerous for AI agents, that is crudding objects and entities, and showing how we're going to constrain that so that it doesn't go and mess everything up, basically. And so what I thought could be a nice way to do that is I have a database here of map tile images. So to me, a map tile is like a scan of a specific latitude and longitude sort of point on a map. And so I found some scans over multiple years. So if we look at this spot in Thailand, we've got this image here from 2009. And then if we go to 2021, we can see that they've added a harbor here. And so this AI agent, what it does is it scans this entire bucket, checks for images that have not been reviewed, groups them by their latitude and longitude, and runs them through Jenny's K&N tool, identifies the things, the classes that are present in that photo, and is smart enough and understands the chronology of photos to identify that in 2021 a harbor was added, but to not add it again when it identifies in 2024, because 2024 is after 2021, etc., etc. So I've got it set up to run this. These are all for the same latitude and longitude location. And when it identifies a new point of interest in a satellite, it's going to add it to this list and sort of link some information. So let me run it now, so we can get some data in there, and then we'll kind of go through all this. So it first got the map tiles. It's now using the chat model. I'm using OpenAI here. I also tested with Anthropic. It was a little less efficient with Anthropic. Anthropic was not batch using some of these tools, but most likely that will evolve over time. So if you're watching this video and it came out 2-3 months ago, double check. These models are evolving very, very quickly. Okay, so it's interacted with a bunch of these tools. We can have a look in a second that order, but let's just check our source of truth. So we've reviewed all the images. So these first 4 that we hadn't processed. So that's good, they've been processed. And we've identified a river and a harbor. And if we look at these images, if we look at the 2003 image, yeah, there is some water here. This is actually the ocean right now, but in the context, I think river makes sense given the training data that we also loaded in there. Again, we could probably load in more differences of ocean and river if we wanted, if that's something that was really important in our use case, but I don't believe our data set delineates that. So that makes sense that it's doing that. That's predictable. And then in 2021, we see this harbor was added here. And then let's see if that's correct. Yeah, in 2021, the harbor was identified. Now, let's run this again for some of these other geolocations that I've got. So we've got a set here. And let's run that. So these are a completely different set of geolocations. To quickly give you an example, this one here started off as a field, lovely field, and then it over time turned into a golf course. So let's see if we can identify that. Okay, it's running. Now, one thing you'll notice when Jenny's tool runs, one thing she mentioned, right? It ran really, really fast. It's in this use case, this isn't happening in a second or two, admittedly, but a lot of the lag is coming from the AI model itself. So again, if this is an async process, something that's not an issue. If real time is more important, there are lots of ways to increase your token per second performance from models. You could be self-hosting models, and at n8n with Ollama, you can self-host your own models as well. So there is a lot that you could do there for my use case that wasn't important. So yeah, so if we open up this, and here we can see in the output, again, I've got a structured output. So the map tiles I reviewed, the points of interest here. This is showing how I'm, again, not necessarily constraining the outputs, but for my own observability, right? So it's going through a switch node here, where then I have a few different cases, right? No points of interest added. Here it was routed out to the new points of interest added case. So again, observability for me. I'm adding it to the no-code DB. I could have had that as an AI agent tool, but I decided I want that to happen deterministically in case I want to retry it, or when I'm in production iterating on this, it breaks it apart and sort of separate the concerns a little bit. And then we've also got the execution data node here, which is basically appending metadata to this execution in n8n, which I can access in the executions tab, which I could later search against and aggregate and that sort of thing. But going back into my AI agent, if we flip over to the logs here, we can see all the different tools it ran and the various details of that. So here we can see that we got the map tiles and we returned a bunch of data on each map tile. This is the longness here comes from signed URLs in NoCodeDB, the database I'm using. So that wouldn't be the case if you're using perhaps a different database. Again, the chat model, it then queries our point of interest tools. And we can see for these different images, we're getting different classes out here. We identify forest, medium residential, golf course, right? And if we go in here, the points of interest, we can see that we indeed added those things for those different images for the correct latitude and longitudes. And then we got the points of interest because we can't duplicate points of interest, right? So it knew to check what is already in there first, and then created various points of interest, and then return structured output. So the text itself is really short here. Again, there's no way for the end user to inject some sort of prompt or something. It's a static, look at this bucket and run everything. And then the system message here, I think, is rather useful. So system messages are basically the instruction book and tone and operating manual for how the task should be done by the AI agent. I usually split it up into sections. Role and task is a really good one to start off with. But this isn't a prompt building guide. There's a lot of folks thinking about prompt engineering and best practices around it. But I would say role and task is super useful header to have, as is context and rules as well. So here we describe how it should do the task, certain context. In the context, I'm defining things like what a map tile is to me, so we have the same understanding. The fact that there might be multiple map tiles with of the same latitude and longitude with different image dates, describing that relationship so it's not ambiguous. And then various rules. So all geolocation should be done with latitude and longitude. Do not create duplicates. Always use signed URLs. I was having an issue with that as I was building, so I added it here and it solved the issue. And I also had a discrete step of instructions on how to complete the task. I removed that because, in fact, it was performing better without it in certain scenarios. It could actually think more independently and do this. So my advice when you're building your prompts, start with less, run it, identify edge cases where it's not performing how you would like it to perform, and then add to your system prompts. Because each character of text you add here could also not necessarily confuse it, but guide it in the wrong direction, especially as models advance. If you add something hacky in here now that sort of helps for some band-aided case, when the model updates, it might be far smarter, and then that band-aid actually limits it, and it doesn't do the correct thing it thought it could do because of some text that you wrote a while ago in your prompt. So in a nutshell, that's what's happening in our AI agent. The tools themselves here are rather simple. If we look at the find points of interest tool, it's essentially expecting a image URL input. We provide an example, and this is enough for my LLM to know how to populate this tool. So this is the image URL it's sending to our tool, like the example data that you saw in Jenny's case. And same thing for a lot of these tools here. So for example, the get map tiles tool, this is calling the NoCodeDB API here. I'm using a credential that's stored on my n8n account, so that's decoupled, it's not stored in plain text here. And then I'm deciding to send a body along, and sorry, forgot to remove that. I'm deciding to optimize the response here. So I'm stripping the raw response that I get. So I feed fileless tokens into my LLM. I would say that's a really important aspect when you're working with tools is don't take the raw responses, take a small amount and feed that into your LLM, just the information that it needs, less to distract it. And then perhaps a great example in the create point of interest tool is how you can specify parameter or placeholders. So here I'm specifying a name placeholder. I'm giving it description, and placeholders are the things that we allow our AI agent to populate when they're using the tool. So here we've got a few parameters that it's using. In here, for example, it's filling in that name. I've got various videos on using tools in n8n on our YouTube, so I won't go on a deep dive on that now. But tool usage in n8n is rather intuitive. And basically what you do is when you add a tool, you define what you want, what's static, what I'm defining, and what I allow our AI to manipulate. So it's an opt-in to what your AI can manipulate. And since each one of these actions I set up, I've deliberately not given it the ability to delete anything. So it physically cannot delete because it does not have an action available to it to call to delete anything. So that's how this use case is working in a nutshell. Here we can see it's added all these, it's processed all these. If I run it again, it should not process any more tiles because they're all reviewed. So we see it got the tiles, it didn't run any of these other tools, it didn't create any, and no points of interest were added based on my switch node here, which is again based on the structured output being returned by my AI agent. So that's all in this use case. I know we're a couple minutes over, so it's probably good that we switch over to some Q&A. We're going into some, there's some meaty concepts in here. I'm sure you guys have a few questions on that. And again, if you want to follow the conversation on this, I'm creating AI and automation content every day. You can follow me on and connect with me on LinkedIn, and I'm posting about this kind of stuff all the time.
Sick. Oh, okay. It's immediately, hey, I wanted to be the one asking the question, but okay. we get the one from the crowd. So we have built production level chatbots using n8n, and we would say n8n is off. Max.
So I can field this question. No problem.
Is this a question though, Max?
So I will say for the record, I do not know Mr. Shah here. This is not a planted question. Our user base is just kind of like this. But yeah, +1 to that. Mm-hmm.
Well, suspicious. Okay. Wow. So we are starting with the compliments. I see. No questions, only compliments, right? Okay. So I guess this one would be for me.
Absolutely.
And actually, a question is the best compliment because that means that people got interest in something, what I'm saying. So what do we have here? I think everybody can see it. Let me read it. Yeah, so number of dimensions actually affects the runtime. I mean, it becomes slower. It's not a problem with the current embedding models which return one vector when they embed, because whatever they return is not that big. There is problem with models like Kolpali, which works with PDFs, which returns a lot of vectors for one picture of one PDF. It's like thousands and thousands of dimensions, then you need to do some optimization. But usually when we are working with these models, which work with text, images, the one that I showed you today, Voyage, which returns 1000 output dimensions, it's a piece of cake. If you want to optimize it, you can use always quantization. And there are 3 types of it. We write about it a lot in our blogs. So once again, quantization. Usually the bigger, it's always the matter of testing, but like you can try scalar quantization as a basis for your vectors, and it's gonna help with the pace of querying. That's the answer. Cosine is always the best method. It is the most popular. There are others. For example, Qdrant supports also dots, and it also supports Euclidean distance. This one is the most popular because it's used by the most machine learning models, embedding models, the ones that take your object and convert it to the vector. When these models train, they usually also apply this distance metrics, and usually they use cosine. It's a good metric. It's the non-biased metric. So as a default, I would advise to use it. Yeah. Max, that is definitely for you. There is like some stuff.
Yeah, sure thing. So you can definitely, and I'm very happy to say this is true. I worked for n8n 4.5 years, seen a lot of like use cases, talked to a lot of people. We've seen a lot of people use n8n to build out a POC, and then you know how it is, like when you're actually building stuff, then they launch the POC is working well, and they plan to like rebuild it in code, and then 3 months later they've delayed the code project because the POC is still handling, at scale, and then I don't know, a year later it's a I like to call it flowgramming, but it's a low code solution that doesn't have native code, where they take one small part of that is getting millions of ops where they see maybe is a little better in native code and do that, but then the rest of the solution where everyone can observe it, modify the prompts as well. Again, a lot of your domain experts probably don't want to be prompt engineering in native code. So yeah, totally can do that, but be warned, you might never switch back.
That actually I think was the problem of that we tried to fit so much in so little time. So let me reiterate a little bit. The question went somewhere. All in all, I understood what it was. Like so the pipeline is like this. Maybe I should actually share the screen once again. Okay, let me just explain like this. So we have image URLs, which we have in our storage, for example, in cloud storage or in Kaggle, doesn't matter. We can just download it to our n8n workflow. Then we're using this image URL and we're uploading it to the embedding model API. So we're using HTTP node, which it can be used for everything. I think literally for everything, like changing governments. I don't know, Max, have you tried? But whatever, so when we send this URL, this API of embedding model knows how to work with URLs of images, and it takes the image and it vectorizes it. So it makes it this vector in the space. Then my workflow, one of the initial ones, by the way, another disclaimer, all of them are going to be published. We're going to write a proper explanation to everything so you can use them, reuse them, perfect them. It's not going to get lost. So my first workflow was taking these vectors returned from this model API and putting like with a batch upload method through our API, Qdrant API, to our database. So now in our database, we have all of these images, for example, of our crops, vectorized and stored. And then once again, when we need to do some operations, for example, find an anomaly or find a class, like depends on which tool we are using, we once again take whatever image we want, convert it once again in my tool into the embedding with this model, with its API, and once again querying our Qdrant vector database with this HTTP node, doing different operations, fetching it, comparing it, and that's how we're getting all the score and the classes. So looks like a black magic, but actually it's just like a sequence of API calls. I feel like I need to do a webinar on this webinar. Let's continue. We can do once again. Let's start over.
A webinar on the webinar.
Hey, Jenny Max, I think that is pretty much all of the questions except for one about talking about knowledge graphs with Qdrant, but I don't know if that would be, make this a bit too long or isn't as pertinent. So I'll leave it up to you too.
Which one though? This one. Oh, let's do a webinar together on that. That is a big one. It's like it's either a lot to say or nothing, because you know what, Maddie, do we have somewhere? I remember sending you QR codes. Maybe we can show them, and yes. Mr. Shah can connect with me, and we can discuss it, or we can discuss it all three, because I think it's a big topic.
That's really good feedback. I guess we got our work cut out for us, Jenny. We're gonna have to go to the drawing board and see when our schedules can align for take two.
I mean,
not a take two. That implies it didn't go well. I think we nailed it. But a V2, let's say.
Yeah, no, we're just gonna do a series. I'm just gonna overpower on Studio. You're just gonna show me every second time.
Perfect.
Okay, we'll just have these last two questions, and then we'll need to wrap up. So the first of the last two is, how would you choose an optimal embedding model?
The answer is going to be disgusting, but it's like experimenting. But yeah, I would say there are like certain leaders which you can use as a default unless they don't work. We can also discuss it on my LinkedIn. I can try to advise you something based on your use case, because I worked a little bit with guys here and there, so I know what works better for what. But for example, this Voyage model that I used, multimodal, so it works with texts and images, and it can compare them. It's actually not bad. I was actually positively surprised. Like, guys from Voyage, please send me all the stuff, like merch. I'm promoting you here. But they weren't bad. Max too, yeah. So I would say trial and error, but we can discuss it. We can discuss it. And what was another one? I saw about more use cases with n8n. I had a small one with a movie recommendations chatbot built on n8n. It's on our Qdrant YouTube. So I am showing actually there how to build it from scratch. So you can guys do a recommendation system also with our combination.
That's a cool one.
And do we have anything else? I see somebody asking repetitively about perplexity. I don't know, Max, is it to you? Can you use
perplexity? I'm not sure I understand the question given the context on the screen.
I think the context was he said, I presume you could use perplexity and then have automatic or automated model switching somehow.
Oh, probably you can.
Gotcha. So I don't know the specific answer on the automatic model switching in AI agents in n8n, so I don't want to say yes or no on camera. But if you're ever using an API that expects an open AI-like API endpoint, so a lot of the open source ones model their schema in the n8n node. If I just share my screen really quick, what you can do actually is open it up, and in the base URL, you can change the base URL. So this is the official OpenAI URL. But if you change this to a different URL of that vendor, perhaps if Perplexity, has that root structure, or some of these open source models or ones that you're self-hosting, like a RunPod or something, then you should be able to do that. So I'm not sure 100% on that answer, but that's the first thing I would check, because I don't believe there's a native integration today for that, but we are looking at some other integrations. And if you want stuff made in n8n, community.n8n.io is where we collect all feedback and whatnot from users to inform what we build.
We also collect feedback, guys. But I see a lot of positive feedback. So thank you very much, guys. I am really thankful to you, and I'm really, really thankful to Max, because you were great, man. That was a pleasure, and I'm willing to repeat this over and over again. I mean, not particularly this, but we can do that also.
Jenny, you're far too kind. I thank you for inviting me on here. Thank you for teaching me a thing or two on the ML side. It's really interesting to me, and it's really cool. I can like consume that with like and kind of understand what's going on, but trust that it works and know that I can go build and do the things that is fun for me to go build and do. So thank you so much. I think Qdrant n8n is an awesome combination. I'm not just saying that because I work at n8n. I really think it's a really cool combo, and the things that you can do. Just with more time, the use case can be that more impressive. I see users breaking it down and really, really complex stuff. So again, thank you so much for getting me involved here. This was really fun. Let's definitely do it again in future. And yeah, thanks to also anyone from the Qdrant community that joined and watched, and it gave me an opportunity to show you kind of what we're working on.
Thank you guys very much. And I think that's it. Can we wrap it up? Let's wrap it up.
Ciao, ciao.
Ciao, ciao.